Where am I? What happened? All right, part two. Random object one here with two positive charges and two negative charges. And then we have random object or material two with three positive charges and three negative charges. Okay, so both is each of them is neutral. And then you rub them together, aka charge by friction. Oh man. When you rub them together, there's a possibility, depending on what material each of these objects is made of, that one of these electrons can be transferred over to the other material. The object on the left, positively charged, and the other material has gained a negative charge, and now it's gone from being neutral to having an overall net charge of -1. Anyway, we've now charged each object by rubbing them together, aka charging by friction. The follow-up question to number 6: when two objects are rubbed together, aka charging by friction, what do the protons and neutrons do? Well, they don't move. They are stuck together in the nucleus. Okay, where do we find that in the reading? Under electrons can move. The protons and neutrons in the nucleus are held together very tightly. Normally, the nucleus does not change. Okay, but the electrons can come or go, but not the protons and neutrons. Okay, they are bound together in the nucleus. If you were try and separate the protons and neutrons in the nucleus, you would get something like a nuclear explosion. Number 7, what happens to an object that loses electrons? It gains a positive charge. What happens to an object that gains electrons? It gains a negative charge. Where's that in the reading? An atom that loses electrons, loses, spelled that. Again, somebody needs to learn how to spell. An atom that loses electrons has more positive charges than negative charges. An atom that gains electrons now has more negative than positive charges, and it gains a negative charge. We have our random object or material of science here, 3 negative charges and 3 positive charges. Right now, it is neutral. If it loses, maybe if it rubs against another material and it loses one of its electrons, it now has an overall charge of +1. +3 -2 gives us an overall charge of +1. We have a random object of science. It has 3 positive charges and 3 negative charges. So right now it is neutral. Let's say that it gains a proton and becomes positively charged. No! No! That's not possible. Where would this proton have come from? This positive charge. Okay? It would have had to come from a nucleus of another atom, which means that somebody had a nuclear explosion in their face. How could this gain a positive charge? Not by gaining a proton, but by losing an electron. Okay, how could it gain a negative charge? By gaining an electron. Now it's negative, okay, or even more negative. It's all about gaining and losing electrons. It's all about electrons. Electro. 9, 10, 11, and so on. An iron atom can typically lose one or any of its protons, become negatively charged. Well, what do you look at that? We just talked about that. That's false. Why? Because an atom cannot lose a proton. Protons are stuck together with neutrons in the nucleus. Okay, that should be green. That should be lighting up green. An iron atom can typically lose one or any of its neutrons, become negatively charged. Explain why that statement is false. Same thing, but phrased differently. An atom cannot lose a neutron. Neutrons are stuck together with protons in the nucleus. Number 11, what happens when an object with a positive charge and an object with a negative charge are brought close to each other? Well, they attract. Because opposites attract. There is attraction. There we go. All right. When an object of positive charge and an object with neutral charge are brought close to each other, you know what? I'm going to save this part 3. Part 3, catch it.